Good day, fellow learners. Today, we will be discussing to you about the lesson Analysis of Variance, or simply ANOVA. But before we proceed, I would like you all to meet the reporters. I am John Eric A. Asuncion.
Good afternoon, everybody. I am Magtangob Maria Janela Pongyan.
Hi, I'm Nicole Grace Espial.
So, what is analysis of variance? An ANOVA test is a type of statistical test used to determine if there is a statistically significant difference between two or more categorical groups by testing for difference of means using variance. In this lesson, we will be having one-way analysis of variance. When an F-test is used to test a hypothesis concerning the means of three or more populations, the technique is called analysis of variance, commonly abbreviated as ANOVA. At first glance, you might think that to compare the means of three or more samples, you can use the t-test, comparing two means at a time, but there are several reasons why t-test should not be done. First, when you are comparing two means at a time, the rest of the means under study are ignored. With the F-test, all the means are compared simultaneously. Second, when you are comparing two means at a time and making all pairwise comparisons, the probability of rejecting the null hypothesis when it is true is increased. Since more t-tests that are conducted, the greater is the likelihood of getting significant differences by chance alone. Third, the more means there are to compare, the more t-tests are needed. For example, for the comparison of 3 means 2 at a time, 3 t-tests are required. For the comparison of 5 means 2 at a time, 10 tests are required. And for the comparison of 10 means 2 at a time, 45 tests are required. So here we have assumptions for the test for comparing 3 or more means. Number 1, the populations from which the samples were obtained must be normally or approximately normally distributed. Second, the samples must be independent of one another. And third, the variance of the populations must be equal. In analysis of variance, we have two different estimates of population variance. We have between group variation, the total variation between each group mean and overall mean. The other one is within group variation. It is the total variation in the individual values in each group and their group mean. Take note that if the between group variation is high relative to the within group variation, then the F-test of the ANOVA will be higher and the corresponding p-value will be lower, which makes it more likely that we'll reject the null hypothesis that the group means are equal.
Blood pressure. A researcher wishes to try 3 different techniques to lower the blood pressure of individuals diagnosed with high blood pressure. The subjects are randomly assigned to 3 groups. The first group takes medication, the second group exercises, and the third group follows a special diet. After 4 weeks, the reduction in each person's blood pressure is recorded. At area equals 0.05, tests the claim that there is no difference among the means. In the table, it divides into 3 parts: the medication, exercise, and diet. Under the medication are the following numbers: the 10, 12, 9, 15, and 13, with a total sample mean of 11.8. Under the exercise are the following numbers: 6, 8, 3, 0, and 2, with a total sample mean of 3.8. While under the diet are the following numbers of 5, 9, 12, 2, and 4, with the total sample mean of 7.6. The total S squared sub 1 under medication is 5.7, while the total S squared sub 2 under the exercise is 10.2, and the total S squared sub 3 under diet is 10.3. Here are the following steps on how to solve the problem. Step 1. Hypothesis: mean 1 is equals to mean 2 is equals to mean 3. Hypothesis 1. At least one mean is different from the other. Step 2. We should find the critical value. Since the degrees of freedom is equals to number of groups minus 1, as stated above, the value of k is 3, so we will substitute it in the given formula so that we can solve it and we can now be able to find the value of the degree of freedom in the numerator, where 3 minus 1 is equals 2 and 15 minus 3 is equals 12. Step 3. Find the grand total mean. So the grand total mean, where total grand mean is equals to the summation of x over n. We simply add all the numbers, the 10 plus 12 plus 9 plus 13 plus 6 plus 8 plus 3 plus 0 plus 2 plus 5 plus 9 plus 12 plus 8 plus 4, with a total of 116. So 116, we should divide it over 15 with the quotients of 7.7.
Let's proceed on how to find the sum of squares between the group. The formula is sum of squares between groups is equal to sigma number of sample sizes times mean minus total grand mean squared over number of groups minus 1 equals 5 times 11.8 minus 7.73 squared plus 5 times 3.8 minus 7.73 squared plus 5 times 7.6 minus 7.73 squared over 3 minus 1 equals 160.13 over 2 equals 80.07. The sum of squares between the group is 80.07. The next step is finding the sum of squares within the group. The formula is sum of squares within group equals sigma number of sample sizes minus 1 times sum of squares squared per group over sigma number of sample sizes minus 1 equals 5 minus 1 times 5.7 plus 5 minus 1 times 10.2 plus 5 minus 1 times 10.3 over 5 minus 1 plus 5 minus 1 plus 5 minus 1 equals 104.80 over 12 equals 8.73. The sum of squares within the group is 8.73. The next step is finding the f-test value. The formula is f value equals sum of squares between the group over sum of squares within the group equals 80.7 over 8.73 equals 9.17. The f-test value is 9.17. Step 4. The f-test value is greater than the critical value, thus it fall under the rejection region, rejecting the null hypothesis. Step 5. There is enough evidence to reject the claim and conclude that at least one mean is different from the others.
That is the end of our presentation. I hope everyone learned something through this video. Thank you for listening and goodbye.